So today we're going to be learning about compound inequalities. Compound inequalities in math are actually quite similar to compound inequalities in English, or compound sentences in English, excuse me, in that they have an and or an or in them. So in a compound inequality, we're going to be using some logic with the and and the or that's actually similar and will transfer over if you go into programming and need to use and or in programming. So when we have an intersection, we're going to have an and with an intersection. So when you have an and, that means that in order for the compound inequality to be true, the number needs to be true, the solution needs to be true for both of the inequalities that make up the compound inequality. For example, if my compound inequality is that x is less than 4 and x is greater than 2, it's only true for the places where it is true for both of them. If it is not greater than 4, it's not, or if it's not less than 4, it's not true for any of it. And if it's not greater than 2, it's not true for any of it. So really the only parts of this compound inequality are true is the intersection, the set where they intersect and overlap. So it's the place where x is greater than 2 and x is less than 4, that just little slice in between 2 and 4. If it's not true for one, it's not true for the whole thing with an and. It's only true where you have that intersection. So a union is a lot less persnickety than an intersection. A union means we're going to take two or more sets and we're going to make them into one set. And if it's true for one, it's true for both. And if it's true for the other one, then it's true for both. So taking our same numbers from before, if we say that our compound inequality is x is greater than 4 or x is less than 2. Well, if it's greater than 4, it's true. If it's less than 2, it's true. And the only place it isn't true, the only solutions that do not work are the solution set in between 2 and 4 and equal to 2 and 4, because I didn't say equal on the others. So a union, an intersection, is going to be smaller than the two original sets, and the union is going to be bigger than the two original sets. So let's look at what this means for us in some real math here. So I've got an and question here, and I know that 2x is less than 8 and x plus 2 is greater than or equal to 7. So this compound inequality is only true when both of these are true, because I have that and there. So let's look and see what this means for us. So I'm going to go ahead and graph 2x is less than 8. So I'm going to go 2x is less than 8. That's great. But I need to know what is happening with just x. So I'm going to divide both sides by 2. So I know that x is less than 4. So I'm going to go ahead and graph that up here. And I have 4. The x is not equal to 4. It's only less than 4. So I have a circle on the 4. And then I'm going to take this line on down. It'd be nice if I could draw a straight line, but I'm pretty sure you can't either, so it's okay. So this is the set of x such that x is less than 4. All right, well, that's great. Let's look at this. We have an and, so we know that they have to be together. But let's look at this set. We have x plus 2 is greater than or equal to negative 7. Okay, so I know that x plus 2 is greater than or equal to negative 7. Well, what does that tell me about x? I really don't care about x plus 2. I don't want the set of x plus 2. I want the set of x. So let's solve for x here. So we subtract 2 from both sides. And we have that x is greater than or equal to, a lot of people struggle with subtraction with negative numbers. We just need to remember that we're already negative and we're getting more negative. If we look at our number line, we're at negative 7 and we're subtracting 2. So we end up at negative 9. So x is greater than or equal to negative 9. And I have an equal sign here. So this one I'm going to fill in my dot because it includes the 9. We didn't include the 4, but we are including the 9, and it's everything greater than that. So if I was able to take this line down and move it on top of this one, I would have the intersection between those two. We want everything. So this one, I forgot to write it, is x such that x is greater than or equal to negative 9. This new set is x such that, well, x is greater than or equal to -9, and x is less than 4. So that's our new set. It's only the things in between these two. So we are at -9 and we're greater than or equal to -9, but we're going to stop at 4 and we are not even equal to 4. So it is only the set of numbers in between this -9 and this -4 for which this is the solution set. So it's a very, very small set. This set was much bigger and this set was much bigger and this set got a lot smaller. Let's see what happens when we have an OR. On this one, we have x plus 2 is greater than 6, or -2x is greater than or equal to 6. But we have this OR. So if it's true for one, it's true. And if it's true for the other one, then it's true. It's not going to just be the intersection. It's going to be if it's true for either one. So let's look at this one. We have x plus 2 is greater than 6. Well, what does that tell us about x? I'm going to subtract 2 from both sides. And I know that x is going to be greater than 4. So I'm going to find up here, it's not equal to 4, so I have a circle, and x is greater than 4. Okay. On this one, I'm going to have -2x is greater than or equal to 6. So -2x is greater than or equal to 6. Again, this is all well and good, but I really need to get it just having the x be alone. So I'm going to divide both sides by -2. Now I need to remember that when I'm multiplying or dividing by a negative is another way of saying the opposite of. Like -x is really just saying the opposite of x. And if x is +3, then the opposite of +3 is -3. And if x is -4, well, the opposite of -4 is +4. So -4 is really the opposite of -4, which is +4. If we look at this in that way, then we can know what to do with this sign. So I know that 2 divided by 2 is 1, but what sign do I put in front of it? Well, it's the opposite of a negative, so it's going to be a positive. 6 divided by 2 is 3, but this negative tells me to take the opposite. It's the opposite of +6, which is a -3. But I also need to apply that oppositeness to this sign. I need the opposite of greater than or equal to, which becomes the less than or equal to. So x is less than or equal to -3. So now I need the union of these two. If I was to just plop this down, there isn't anywhere where they intersect, but it's okay that there isn't anywhere that they intersect because we don't care if it's true for both of them. We just care if it's true for either of them. So I bring this graph down and I bring this graph down. So this one up here is the graph of x such that x is greater than 4. This is the graph of x such that x is less than or equal to 3. Oh, I did that in purple. Just pretend that it's in green, all right? We'll change this one to red. Well, this is the graph. Oh, goodness, I messed that one up. X such that x is less than or equal to 3, or x is greater than 4. With the and, we were able to combine it into one statement. X is greater than or equal to 9, and x is less than 4. With the or, we have to use the word or in there still. So let's look at some kind of interesting cases though. We're going to solve 2x plus 5 is less than 15, or 5x plus 15 is greater than 20. And then we're going to graph the solution set. So I'm gonna do this in the purple and the green again, and then I'm just gonna do it all on one number line. Okay, so 2x plus 5 is less than 15. That's gonna take a couple more steps to solve, but that's okay. I can do that. So we're gonna do this one in purple. 2x plus 5 is less than 15. So my first step before I go, I know I'm gonna need to divide by 2 because I have a 2 multiplied by the x. But we really need to combine like terms before we start multiplying and dividing. So here's a constant term, here's a constant term, so let's get them together. So I'm going to subtract this 5 from both sides to combine them, which gives me 2x is less than 10. And then I'm going to divide by 2 to get this x alone. So I have that x is less than 5, okay? So I could write it as x is less than 5, and this goes on forever. This is an or, so this isn't going to be where they intersect. It's going to be true for all of them. So let's do this one. 5x plus 15 is greater than 20. So again, I need to combine like terms before I go multiplying and dividing things to get the x alone. So let's subtract 15 from both sides. And I'm going to end up with 5x. Oh, I put an equals on there. That is not. I was thinking about how we don't have any equals then, or greater than or equal to or whatever. And then I went ahead and just added it in on my own because I felt sad. 5x is greater than 5. Divide both sides by 5. Divide both sides by 5. X is greater than 1. Okay, so we've got a little circle here. X is greater than 1. So we need the solution set of where these are both true. Now, they have an intersection actually, right here in between -1 and 5, but this isn't an and, this is an or. So where are these both true? Well, these are both true actually everywhere, because this one is true from here on up, this one is true from here on down. They're both true everywhere, so our solution is the set of all real numbers. If it's a real number, it's true for all of these. It's true somewhere for one of these equations or one of these inequalities. So it's true for all the real numbers. And I don't need to have x such that blah, 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 blah. I just say, it's just all real numbers and we're good. And we're going to go home. Let's do one last one. This one is an and. So we're going to look at where these two graphs intersect. Okay. So we're going to do the purple one, the first one in purple again. And we're going to do the second one in green again so we can keep them separate. Excuse me. Excuse me again. I am not remaking this video because I sneezed. So you just get my sneezes. There you go. Merry Christmas. Have some sneezes. All right. 3x plus 5 is greater than 17. Okay. So my first step is I need to subtract 5 from both sides before I can go multiplying and dividing that 3 away. Right? So we're going to end up with 3x is greater than 12. I don't need 3x, I need x, so we'll divide both sides by 3 to get the x alone, and we have that x is greater than 4. It is not equal to 4. It's, once again, we don't have any equals here, so I need to be sure I don't accidentally sympathetically draw one in because I miss them. All right, so greater than 4. All right, so we need 10x plus 12 is less than 22. Now remember, this is an and, so it has to be true for both of these or it's not true for anything. So subtract 12 from both sides, subtract 12 from both sides. We have 10x is less than 12. 22 minus 12 is 10. Divide both sides by 10 to get that x alone. And we have that x is less than 1. So it's not equal to 1, it's just less than 1. All right, so we need our solution set is the place where these two graphs cross. Except they don't cross. They don't cross anywhere. There is nowhere. They don't wrap around. This isn't a circle, this isn't the earth. We are a flat plane society. We're not a curved plane, right? So they don't intersect anywhere. So what? what's my solution? Well, I don't have one. I don't have a solution. This is the sign that means no solution. There is no solution set for this. I don't have X such that X blah, blah, blah. I just have no solution. There is nowhere in the universe that it's going to be true for both of these. It isn't, and so it's not going to ever happen that it happens for both of these. Good luck with all your things. Let me know if you have any questions. Goodbye.